Hello everyone, it's Casey Vineyard here at Wonders of Wildlife National Museum and Aquarium. We are so excited to have you here as we continue to talk about our mission for the month of August through Mission Conservation Sharks. Throughout the month of August, you will get to meet multiple partners to learn exciting facts about sharks. Get ready to dive into some fun facts about these amazing animals. In order to play this really fun mission, all you have to do is swim on over to our Mission Conservation page at www.wondersofwildlife.org/mission-conservation, and that will bring you to our Mission Conservation webpage. On this website, I will bring your attention down to get the app. Once you click download, that'll take you to download the Agents of Discovery app, which you will need to play any Mission Conservation mission. Once you have that app downloaded, create a user account and log in. Hit the search bar, type in Mission Conservation. This is where all of our at-home missions will pop up for you to play. Once you have the mission popped up and loaded, hit play and get ready for your fun adventure. And if you're looking for more shark-related activities, we're going to direct you down to another part of the website where it says Schedule of Missions and Activities. This tab will show you all of the missions we have live, including our current mission, Sharks. Under this tab, you will also find our activity guide that we have specifically made for you at home. There will be a craft, an awesome outdoor activity, and something you can do to promote conservation for sharks and their importance to our ecosystem. So I'm currently standing here in our forest classroom in our John A. and Jenny Morris Conservation Center. Behind me, you may notice a variety of artifacts. We use these classrooms as a tool for educating, and that brings me to our partner for the day. We have Audrey Moore, a lead educator here at Wonders of Wildlife. She is going to lead a dogfish dissection and discuss the anatomy and physiology of this shark species. Welcome, Audrey. How are you doing?
I'm doing great, Casey. How are you?
That's so great.
Good.
So I'm going to leave you to dissect the sharks. So you guys enjoy.
Good. Alrighty, so today we are going to be talking about the Atlantic spiny dogfish. So before we get into the dissection, I just want to give you a little bit of background information. So like I said, the Atlantic spiny dogfish, or the Squalus acanthius, is also known as a couple other common names throughout the world. So the dogfish shark, the Cape dogfish, the grayfish, or even the piked dogfish. These guys are very slim and narrow in body, very streamlined. They have a pointed snout and they have characteristic white spots going down the sides of their body. They usually have a gray coloring along the top and white bellies. They have two dorsal fins, so two fins that stick up along their backs. And they have two ungrooved spines, which I'll show you where they are on the shark in a minute. They usually grow to be about 3.3 feet for the males, and females are around 4 feet long. So the females are just a little bit larger than the males. In terms of mating and reproduction, these guys are very similar to a lot of other sharks. They grow very slowly and they mature pretty later in life. So they usually live about 35 to 40 years. The females can reproduce at age 12, whereas the males can usually reproduce around age of 6. They spawn in the winter in offshore shallow waters. The females usually will have about 2 to 12 eggs per spawning season. And the way these sharks reproduce is their eggs are fertilized internally. After a gestation period of about 18 to 24 months, the female dogfish will actually bear live young. And they average about 6 pups, and we'll go more into their reproduction a little bit later. These guys are opportunistic feeders like most other sharks, and they will pretty much eat anything that they can find. They feed on what is most available. The smaller dogfish will usually feed on things like crustaceans, while larger dogfish usually eat things like jellies, squid, and schooling fish. They are a pretty small species of shark though, so they do have quite a few predators, usually cod, goosefish, other spiny dogfish, larger sharks, seals, and even orcas can eat these guys. And they can be found in mostly temperate and subarctic areas, mostly in shallow water areas and bays. You can mostly find them in the northern Atlantic and parts of the northern Pacific as well, but like I said, they're usually along those coastlines. Some fun facts about this species, or one fun fact about this species, is that they are commonly found in Europe as the fish in fish and chips. So what I'm going to do is I'm going to switch my camera on over so that we can look at this shark. All right. And as we get switched over, I'm going to throw some gloves on really quick. So you are looking at the ventral side of the shark, or the belly side of the shark. We'll do a quick look at the exterior anatomy, or the anatomy on the outside of the shark. And so to start, we will look at the dorsal side. So we're going to flip this shark on over for just a second. So I mentioned that these guys have two dorsal fins. So we have one here and one over here by my fingers. You'll see these little grooves right here in front of the dorsal fins. That is where their spines are usually at. So like I said, they have those long ungrooved spines that stick out. Those are for protection. They are cut off of this shark as a precaution for people who are using them for science and dissections, so that they don't get pricked, and also so it doesn't cut through the bag that they're shipped in. But as we're looking at the shark, you can see the pointed nose that I was talking about. So they've got a really pointed nose, very slim and narrow body. They have those white spots that run along the sides of the sharks. And they have a couple really cool things in terms of adaptations, or things that they use to help them live or to stay alive. So they have what's called a lateral line system. Like most fish, it runs all the way along their bodies. And this is a sensory system that detects movement and pressures changes in the water. So they're actually built into their body kind of as, or it is another sense for them. They also have a kind of branch of that lateral line system called the Ampule of Lorenzini. This is a modified system of the lateral line, and it actually detects electrical fields and helps them find prey by detecting the movement of electrical fields generated by the activities of their prey items. We also have the nares. So those are actually on the ventral side. So see the little holes. The little holes on this side here, we have, you can't see it, there it is. Those are the nares. So very similar to our noses, these are another sensory system, and they detect odors in the water. They have gill slits like other sharks will have as well. They're going to be right here. This shark has 5, and of all the shark species, sharks can have 5 to 7 different gill slits, just depending on the species. They have to have these gill slits because instead of having an operculum, or a hard cover like a bony fish would, they have these exposed gills, so water is constantly flowing over them. Most species of sharks continuously swim, and so that helps just allow water to be constantly flowing over those gills. But they also do have another body part called a spiracle. It's right here on top. And these are another way that they can push water in. They put it into the buccal cavity and then push it out through their gills. So they have 2 ways of getting water to their gills, but the most prominent is going to be these gill slits. They also have lots of fins because they have to be able to move through the water. So we talked about their dorsal fins, the 2 on top, and those are going to help the shark from rolling, as well as keeping them stable in the water. So those are their stabilizing fins. They also have their pectoral fins, which are these ones on the sides of the shark. And these are helped for steering and lift while the shark is swimming. We also have our pelvic fins, which we're falling out a little bit here, that's okay. We have our pelvic fins here, and these are also just to help stabilize the shark. Some species have more fins, some species have less fins, but this is what the spiny dogfish has. And then on the end here, we have our caudal fin. So a lot of people call this the tail, right? So they have 2 lobes. They have an upper lobe right here and a lower lobe. And the caudal fin is mostly used as similar to a boat propeller. It's used for locomotion and to push the shark through the water. So that's what propels them through the water. So that's what I have for fins. And then Most people probably haven't touched a shark, but if you've ever touched a shark, it feels very similar to sandpaper. It has a very rough texture, and if you go from nose to tail, it's going to feel very smooth. But if you were to rub your hand from the tail all the way up to the nose, it's going to feel very sandpapery, or it's going to be very rough to touch. And that is because they have, instead of like a normal fish scale, they have what are called placoid scales. These are small plates that form the skin of the shark. They're kind of like a modified tooth where they're covered in an enamel-like covering, and they are able to protect the shark from predators, but this also helps streamline their bodies and make water kind of flow off of them and help with hydrodynamics as well. These guys are similar to birds and reptiles and most fish that have a cloaca. So this is for females, it's the entry to the sex organs. For all of them, it's going to be the exit for all of their digestive and waste systems. And this actually is a female, but if we were to have a male shark on the screen, he would have claspers. I like to tell kids here at WOW when they ask, oh, is it a boy or a girl? Fingers or flaps. So claspers look very similar to fingers. So they'll have fingers right back here by the pelvic fins. She's a female, so she's got flaps. So just her pelvic fins are what you look for. All right. So let's go ahead and take a look at the internal anatomy. I want to start with the digestive anatomy because I think it's very interesting how these guys kind of work and survive in all the crazy things that they like to eat. So we're going to open this guy or this girl up. So the first thing that you will notice is going to be right here on the sides. So this is actually the shark liver. And if you notice any of this red or yellow stuff, it is not blood. It is actually dye. So when you order these sharks, they dye the different veins and things like that so that you can see kind of blood supply and other different things. So I promise it's not blood. It's just dye. So this is one lobe of the liver. They have a double lobed liver. That's a tongue twister. And these are very slippery because they are covered in oil. So this liver will concentrate and store oils and fatty acids. And the liver functions in energy storage, but also in buoyancy. Sharks don't have a swim bladder or a pocket of air like most bony fish would have. So they use this liver to generate all that oil, and oil floats in water. So that helps with their buoyancy. They don't need a whole lot, but they do need a little bit of help in the buoyancy department. So under this, and it might be kind of hard to see, make sure we're focused here. So this little green lobe, that is actually their gallbladder. And then we have, we're going to go ahead and start with the digestive tract. So obviously here is her mouth. And then from there, got dye all over me. From here, the shark's going to eat it. It's going to go into the esophagus. With the mouth, it's really hard to open with these guys, but we've talked about on previous live streams, sharks having rows of teeth that are replaceable. So it will go into the esophagus, and then we will have it go into the stomach opening. So these guys have two stomachs actually. They have a cardiac stomach, which is this first one, and then they have their pyloric stomach. So for the cardiac stomach, this is usually where things are found mostly whole. These guys will have really, really strong stomach acid that can break down bones and scales and all kinds of other different things. But if they cannot, then they are actually able to regurgitate it. And all of that is regulated in that first stomach, the cardiac stomach. After that, it will go into the pyloric stomach. And these guys have a J-shaped stomach. So up here, right here, is where the cardiac stomach is, right by my thumb. And by my other thumb that's wiggling right here, that J shape is going to be the pyloric stomach. And we are going to go ahead and cut open the cardiac stomach. So if you have a queasy stomach, maybe don't look at this part, just listen. But what we'll do is we'll just do a quick little snip. We're going to look into the cardiac stomach and see if there is anything in there. Feels a little thick, so there might definitely be some food in there. Let's see what we can find. All right, so we're going to open this guy up, and it looks like a lot of just goop. But I do want to open it, and it, like I said, it is a little gross, but it is really cool to be able to see the internal parts of their stomach, because they actually have these little ridges, and these ridges are what help expand their stomach like a balloon. And that's why they're able to eat so much, because they know that they might not be able to find their meal as quickly as they did the one before. So they're able to eat quite a bit, expand that cardiac stomach, and they have a very slow digestive period. So they're able to keep it in there and kind of provide nutrients to their body a lot slower and store that food in that stomach. So they have to make sure that it can expand. And then it goes into the pyloric stomach, and this is where the main breakdown of food goes. So this is where they'll start to get all of their nutrients for their energy levels and all of that stuff. And what we have is, after that, we have our spleen. I'll just go over some kind of random ones really quick. So we have our spleen. Our pancreas is going to be, they're kind of hard to find. I don't see him, but if I do, we'll find it. We'll find it. All right, so we'll go ahead and move from, so we started at the mouth. We went down the cardiac stomach to the pyloric stomach. Now we're going to move into the intestines. So they don't have a small and large intestine like we do. They have strictly a small intestine. Cool thing about their intestines are they're actually spiraled. And so there's ways that they can help compact, and they will also absorb nutrients a lot better. Like I said, that digestive process is really slow. So the absorption happens at a really concentrated level. And most of it will go into this spiral valve inside here. I will open it up if we have extra time, but usually it just looks like a bunch of brown mush. But that is what they mainly absorb. And then things will move down here to the colon, which we might not be cut open quite enough, but it will move to the colon and then out the cloaca right here. And that is how they digest the foods that they eat. Then from there, I would like to quickly talk about the reproductive system, because it's something that I find really fascinating. So these guys, like I said earlier, are ovoviviparous. So they have eggs inside that are fertilized internally. The babies grow inside and then are inside those eggs and then are bared live. So we'll take a quick look at her reproductive systems really quick. So up here on both sides of kind of underneath the liver flaps, we have the ovaries. So she has one on each side of the body, and her eggs are actually stored in these ovaries. And so this is what an egg looks like. They're pretty homogeneous all the way through. So if I were to cut kind of down the middle of it, it would look exactly the same all the way through until they're fertilized. And then it obviously would look a little bit different, but they just kind of look like little marbles to start. And what happens is the eggs are brought down into the, and it might be easier to see. Yeah, it's much easier to see on this side. So you see an egg up here. And what happens is they are put into the oviduct, which they're not kind of inflamed or large right now, but usually there's little membranes that run all along the body here The egg will move down here. It'll be fertilized in this general area, kind of along the side of the shark. And then the shark will pass it through this kind of shell covering and pass it down to the uterus, which is right here. I don't know if you can see that right at the point of my finger, the uterus. And the eggs will sit in there for quite a while. They're, like I said, their gestation period is about 22 to 24 months, so almost 2 years. They will hang out in there and they actually absorb the yolk and don't get a whole lot of nutrients from the mother herself. So that is why they're ovoviviparous, because they don't get nutrients from the mom. For the most part, they get nutrients from that yolk of the egg that they kind of originated in. And they are called pups when they come out. And they actually, I have a specimen that we collected from another dissection, and they are right here. I don't know if you can see with the glare, but they just look like really, really teeny tiny dogfish sharks. So basically just a miniature scale, but they're very small when they come out and they kind of have to fend for themselves, if you will, after that. So that is how they reproduce, at least on the female side. One more thing before I finish up here. I have a couple kind of random anatomy things that we can look at. So the first thing is this little red piece right here. This is our rectal gland, and the rectal gland has a very important purpose. It is used to excrete sodium chloride out of the body. So sodium chloride is salt, and these guys live in salt water. So this helps them osmoregulate in all of their bodily fluids. We looked at all of the digestive tract, but I'll kind of give you a location of a couple other things. So they do have a fairly not complex circulatory system, so blood flow system. So their heart is right here, just below the mouth in terms of positioning. And it is fairly small, but it pumps oxygenated blood to the entire body. And there's a whole reasoning why this is, but we don't have a whole lot of time today. And usually these dissections here at Wonders of Wildlife, we take about an hour, but honestly, I could do these for hours upon hours upon hours. There's so many adaptations and cool things that these guys have. But that is a pretty general overview. I did want to get up close and try to show you the ampullae. So there are these little dots along the nose. I don't know if you can see that. Yeah, you can. Those little dots, they look like little pores along their nose. That is that sensory system for electrical fields. And they are able to sense those changes in the electrical fields from there. So I think that is all that I have for you today. So we're going to switch back over, and that is all that I've got.
All right, sorry, it takes a minute for that camera to switch back over, but Audrey, I did have a question for you.
Yeah.
How do you know so much about all of this?
Yeah, so I actually attended, I'm from Springfield where Wonders of Wildlife is, but I attended a college, Eckerd College in St. Petersburg, Florida. I have a biology bachelor's of arts, but all of my classes were marine focused. So that is how I know so much about sharks.
Well, thank you so much for joining us
Absolutely.
today, Audrey. It was a pleasure to have you to talk about the anatomy and physiology of the dogfish. So that is all the time that we have for today, but be sure to join us next week as we talk about our new Smoky Bear mission that we have partnered with the USDA Forest Service. That's going to take place at 1 p.m. Central Standard Time. Thank you so much for joining us, and we will see you next week.